So today we are going to start our Unit 4, which is going to be over something called sequences and series. So today we're going to talk a little bit about sequences, and then we're going to get into a specific type of sequence, and then we'll pick up on Monday with series. So you can go ahead and label this first section of your notes for this Unit 4.1. These are going to be something called arithmetic sequences. Okay. So first thing that we need to do here is we need to define what is a sequence. Alright, so sequences, you actually see these all the time and you just don't know it. A sequence is a set of numbers defined by a pattern. Okay, so math, the real world, anything really is all about looking for patterns. Sequences are a way of putting formulas and names to what these patterns are. So what we're going to do here at the beginning is just lay out some basic things about a sequence, about what sequences are, some different questions I might ask you regarding sequences, and then we'll get into the more specific type of sequence, in this case arithmetic, in our second video. So for our first example, what I want us to do, and we'll have probably like 5 or 6 just little examples here, is we're going to list out the first 5 terms of a few different sequences. Okay, and the way that sequences will be listed, we'll kind of look, or sorry, the way that we'll see sequences defined is sort of like this. So let's say that we had a sequence. We'll call this B sub n. And our formula here is going to be 1 over n. Alright, so I'm starting out with a super simple one here just to give you guys an idea of what this means. So if I want to find the first term, well, that's b sub 1. All this means is I'm going to go to my formula and I'm going to plug in 1 for n. So I get 1 over 1, which is 1. Okay, b sub 2, which would be 1 over my n value is 2, so I get 1/2. And hopefully you should be able to see here, this would be 1, 1/2. The next term would be 1/3. The next one would be 1/4, 1/5, and so on and so forth. Okay? So if we're given a formula to define our sequence, we can go through and we can list out terms of that sequence by using the corresponding n value for whatever term in the sequence that is being asked for. Okay? Let's try a couple more like this. So let's go example 2 here. Let's look at this. Okay, b sub n is going to be defined as -1 to the power of n plus 1 times 2 to the n power. Okay, and my recommendation for doing any of these is literally to just start out with b sub 1, and wherever you see an n, plug in 1 and see what happens. Okay, now if you could start to see a pattern, like we kind of did on the last one, where we noticed that whatever term in the sequence it was, that was the number in the denominator. You don't need to list it out for every one, but you should always start by just plugging in this case, 1 for n, and seeing if you could see a pattern. Okay, so if we think about this, this becomes -1 squared, and anytime I square a number, positive or negative, it becomes a positive, and 1 to any power is 1, so this is going to be 1 times, I'm sorry, I should plug in 1 right here for n. 2 to the first is 2. So in this case, I get 2. Okay, if I do b sub 2, I get -1 to the 2 plus 1 times 2 squared. Okay, this becomes -1 cubed. A negative number to an odd power remains a negative, so we're going to get -1 times 2 squared is 4, so I get -4. Okay. Let's try b cubed, and then let's see if we can identify a pattern from here. We'll go -1 to the 3 plus 1 times 2 cubed. Alright, if I do -1 to the 3 plus 1, this is to the 4th power. A negative number to an even power is always positive, so this becomes 1 times, and 2 cubed is 8, so this becomes 8. Okay, so what we'll see here, let's see if we can write some of these out and see a pattern. We've got 2 to the first, then we've got 2 squared, then we've got 2 cubed. The next one's going to be 2 to the 4th, which is 16, but notice what's happening to the signs here. Positive, negative, positive. This next one is going to be negative. Okay. The next one's going to be 2 to the 5th, but, as we can suggest here from the pattern, positive, negative, positive, negative. This next number is going to be positive, and 2 to the 5th is 32. And if we extended this out, what we would notice is the signs for each number would alternate, and we would just be raising 2 to 1 power higher each time. So 2 to the 1st, 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th would be 64, but in this case our sign would change. Okay, next one would be 2 to the 7th, 128, but it would be positive, and so on and so forth. Okay, so if you kind of see what's happening here, we are raising 2 to a power each time, and our signs are alternating. Okay, that's what's happening here with these terms in our sequence. But first 5 terms of this sequence right here would be those 5. Okay, so keep this in mind. This -1 to the n plus 1. If you ever want to make the signs on your terms alternate, this is a pattern for what we can use, and we'll get back around to this in a little bit on another example. Okay, let's try one more like this. Example 3. For this one, we've got b to the n equals 1 over 2 to the power of n minus 1. Alright, and again, like I said, started out with just plugging in 1 for n, and let's see if we can see a pattern after we do a few of these. Okay, so 1 minus 1 is 0, 2 to the 0 is 1. Okay, so 1 over 1 gives me 1. Alright, try b squared. I'm going to plug in 2 for n this time. 2 to the 1st is 2, so I get 1/2. Okay, let's try b cubed, and then let's see if we can see a pattern. Okay, 2 to the 3 minus 1. This becomes 2 squared, which is going to give me 1/4. Okay, maybe let's see if we can do one more here, and then we'll check a pattern. Right, 1 over 2 to the 4 minus 1 gives me 1 over 2 cubed, which is 1 over 8. Alright, if you take a look at the bottom of each of these fractions, what you'll notice is the bottom is doubling every time. Okay, and this was 1 over 1, double that you get 2, double that you get 4, double that you get 8, double that you get 16, double that you get 32, and so on and so forth. Okay, so we're seeing kind of, here's the first 5 terms, we're seeing how that pattern is laid out based on the formula that was given to us for that sequence. Okay. Alright, now we've seen how you can list out some terms. What I'm going to do next, we're going to flip the script a little bit. And instead of me giving you a formula and asking you to list out the terms, what I'm going to do is I'm going to give you the first 5 terms, and we're going to see if we can come up with a formula. So for this first one, we've got 2, 4, 6, 8, and 10. And let's come up with a formula. Okay. We cannot write, so let's fix that. Come up with a formula. Alright, so here's a good way of doing this, in my opinion. If these are the terms of the sequence, the first term, b sub 1, is 2, b sub 2 is 4, b sub 3 is 6, b sub 4 is 8, and b sub 5 is 10. Really what you're looking for here is, can you find a relationship between the number that term is in the sequence and the actual term. Okay, the first term is 2, the second term is 4, the third term is 6, the fourth term is 8, the fifth term is 10. What you'll notice here is the number of the term is getting doubled to find the actual term in the sequence. So what that would look like is b sub n is the number that the term is times 2. Okay, so if I wanted to know what's the 100th term in this sequence, well, I can see here 2 times 100, the 100th term in the sequence would be 200. Okay? So what we're doing here is we're looking for a relationship between like the number that the term is in the sequence and the actual term in the sequence. Okay? Let's try a couple other ones here. just so you guys know, I have a 15-minute limit on each one of these videos. So if we cut this video off and go to another one, you'll know why. So here is the next one. 1, -4, 9, -16, and 25. Okay. Again, let's try this. B sub 2, 4, B sub 3 is 9, B sub 4 is -16, B sub 5 is 25. Okay. Alright, so trying to come up with a pattern here. First of all, notice the first term is 1, second term has a 4, we'll worry about the signs in a second. Third term is 9, fourth term is 16, fifth term is 25. The way that we get from this subscript to this actual term every time is we take that subscript and we square it. Okay? That should be fairly obvious, hopefully, to everyone as they're watching here, that we square whatever the number of the term is in the sequence, we square it to get the actual term. Okay? Now what we need to account for is the fact that these signs are changing. Okay? It starts positive, negative, positive, negative, positive. We've seen that before when we tried example 2 right here. Okay? Notice here, positive, negative, positive, negative, positive. The way that we make those terms alternate is we take -1 and we raise it to a power. Okay? Now, as we mentioned earlier, when you raise a negative number to an even power, it's positive. When we raise it to an odd power, it's negative. We need to test here, is this going to be to the nth power or to the n plus 1 power? Well, let's try it. If I tried this to the nth power, when I plug in 1 for n, -1 to the first is -1. Okay, well I want this first term to be positive, so I can't just have this to the nth power. I need to do this to the n plus 1 power, so that when I plug in 1, -1 to the 1 plus 1, this is squared. -1 squared is +1 times 1 squared. That would give me a b sub 1 of 1 times 1, which is +1, which is what I want. Okay, so here is the equation for this. This part alternates the signs from positive to negative for each number, and then this last part right here squares the term. Okay, so we see our pattern happening here in this problem. Alright, one more here for this. Again, right now we're just talking about generally what our sequence is, and after this we'll get into a specific type of sequence. Okay, so I've got a couple minutes here for this example. So here are our terms: 1, 1/3, 1/9, 1/27, and 1/81. Okay, and again, I recommend that you do this. Okay, because we are really looking for, is there a relationship between the subscript and the actual term in the sequence. Okay, now what you'll notice on this one is all of these numbers on the bottom are, denominators are 3 raised to a power. Okay, this is 3 to the first, 3 squared, 3 cubed, 3 to the fourth. Okay, so I'm going to make a note here. This is 1/3 to the first. This is 1/3 squared. This one is 1/3 cubed. This one's 1/3 fourth, 3 to the fourth. If you can make an inference here, this one should be 1/3 to what power? Well, notice that this just goes down 1 every time. This is probably going to be 3 to the 0 power. Well, this makes sense because 3 to the 0 is 1. 1 divided by 1 is 1. So if we're trying to write this out, this would be b to the n equals 1/3 to some power. Okay. Well, look, when this 1 is the subscript, the power is 0. When the subscript's 2, the power is 1. 3, 2, 4, 3, 5, 4. What's happening here? Well, we're taking the exponent and we are subtracting 1 every time. Okay, and this gives me this particular sequence.